Hello guys, welcome to Python and Machine Learning Daily. One of the top usages of AI these days is chatbots, personal assistants, customer support agents, and stuff like that. So in this video, I will teach you how to build your personal chatbot based on your documents, your FAQ document like this one. So you have questions and answers from your website or whatever, and you need to build a chatbot to answer your customers' questions. So we will do that with Python using OpenAI GPT-3.5 Turbo as LLM model and LangChain framework to tie it all together, and we will have two visual results: this web that you can see on the screen and also terminal-based chatbot. So you would be able to ask, what is the price for yearly plan, for example, and the chatbot would answer in a few seconds, this is the price. And this video is a video version of the text-based course that I've published on my pythonmldaily.com, and I will link that text course in the description below as well if you prefer reading instead of watching. And also the source will be available on GitHub, the link will be in the description below. Now let's go build our chatbot. We start with the overall plan of action, kind of like an overview. So we have the initial knowledge base, I call it knowledge base, CSV, PDF, JSON, database, or whatever format you have. We need to transform that into embeddings and store that in the vector database so that computers would understand it. Computers don't understand text, but they do understand numbers, which will be called embeddings. And then from those embeddings, we need to find the relevant pieces of information, relevant documents to the search query. And that search query comes from the other side, from the terminal chatbot or from web. They ask a question, and then LangChain framework will help us to tie it all together in just a few lines of code. That's why we need it, so it would search for relevant documents, pass them to the OpenAI GPT model, and then provide the answer back to the chatbot. So this is the overview. Next, I will list the libraries that we will use. You may want to install them upfront with pip install to your machine or to your virtual environment, but this is your personal preference, whether to run those upfront or run them one by one as we need a specific library. Now keep in mind, in this video we are taking only one set of tools. So for LLM model I've chosen OpenAI GPT-3.5, but there are dozens of other options. You have open source models like Llama 2 and others. Also, you may want to use something else instead of LangChain like Llama Index. So you need to understand there are dozens of choices for each of the steps of the chatbot. And in this video I will show you probably the most simple one, so you would understand the full picture, the full ecosystem, the process, and then you would be able to experiment with different tools for each part of the chatbot. Now let's start actually writing Python code. As it is typical on this channel, I will copy and paste parts of the code instead of live coding to save you some time. So this is the first part. We need to read our CSV into some kind of variables. And those variables could be Python lists, but since we're using LangChain framework, it makes sense to immediately transform the data into LangChain document type to be processed later. And in this case, PyCharm underlines the LangChain because I haven't installed it, and I can install it just like this with PyCharm here, which under the hood executes pip install LangChain. Okay, installed successfully, and now we can do something like print documents. So what would be the structure of the documents that we have? And this is the result. The list, Python list, and each list item is a document. Document is typed from LangChain. In each of the documents we have page content, and if we scroll to the right, a few more things like metadata, source, and row. Now we need to transform that into embeddings. Let me explain what embeddings are. Embedding is a number representation of any string like text, word, phrase, or sentence or paragraph, which is unreadable for humans but perfectly readable for the machines to find the similarities between different embeddings. And how those embeddings work is that we transform into embeddings both our answers and the chatbot questions. And then the similarity search mechanism, which we will get to that in a minute, searches the vector database for relevant documents and then pass those as context as additional information to the OpenAI GPT. So the GPT chatbot answer will be based on combined our documents, our context, and the knowledge of GPT itself. To transform the text into embeddings, we will use a library, OpenAI Embeddings. Keep in mind it's not free and you should check the pricing page of OpenAI. So this is the new line. Again, we imported from LangChain, and this is where LangChain should start to get clearer for you what it does. It has a lot of libraries and functions in itself to work with different providers of LLM, of embeddings, and other things that chatbots need. So we import OpenAI Embeddings, and this is just an example from the official documentation of embeddings, and I will show you what embeddings are. Before doing that, I need to provide my API key from OpenAI, and you can get one in your platform OpenAI.com, create new secret key, let's call it chatbot video, and I will disable it immediately after that video is finished. And by the way, if you don't do that, a sign of warning: if you leave your secret key, the API key, in the code and publish it somewhere on GitHub, you may get this warning email from OpenAI, which would automatically disable that API key, which is a great security measure because otherwise someone else may misuse that key and you would get charged for that. So yeah, anyway, don't publish these keys anywhere, but for now I will copy and paste it into the code like this, with a warning that you shouldn't do that. This is just for demo purposes. Now if we launch this in PyCharm, we will get an error, could not import OpenAI. We need to run pip install OpenAI. So I will do exactly that in my terminal, and if we rerun again, we get another error that we need another package called tick token. Okay, then another package to install with pip install. And now if we run, this is the result. We print out the embeddings for these two phrases. And these are the numbers down below. This is a very big number, another one, and there's a huge list of those numbers. So this is how embeddings look like. But don't worry, we don't need to work with them manually. This is where, again, LangChain will help. The next step is to store those embeddings in a thing called vector database or vector store, because OpenAI provides the OpenAI embeddings as a mechanism to transform the data, but not to store it. And there are many options where to store them. We will pick one of them called FAISS that comes from Meta, from Facebook. And again, LangChain will help us with importing that as a library. So we just need to write a few lines of code to tie it all together. Create the model of embedding and then pass that model into a function of creating vector store. So this will be our vector database object from documents, from these documents, which will also pass with that embedding model. If we launch that, we get an error that we need FAISS package. This is another thing to install with pip install FAISS GPU or CPU. In my case, I will use CPU for now. If you have GPU that is compatible and you want to use it, feel free to have GPU installed. And now if we run, it should be successful, but we don't really actually do anything yet. Process finished, exit code 0, no errors. Good. And yes, I know it's getting a bit boring because we haven't really asked the chatbot yet, but we will do so in the next step of using OpenAI. But before we do that, I want you to understand another concept called Similarity Search. So how vector store searches for relevant data. We add another 2 lines calling Similarity Search on a specific query, and it will find similar relevant documents in our documents from CSV. So if I launch it, ignore the warnings for now. This is the result. The document with the content "What are your pricing plans?" is considered the best match to our query. But for example, if we change the query to "Do you have discount coupons?", the result will be different. The first document is any discount coupons based on countries. So this is how Similarity Search works with embeddings. And again, we will not have to launch that manually. LangChain will help us. Now let's finally launch a query to the OpenAI GPT model. For that, we import two other things from LangChain, which is chat model chat OpenAI, which would actually connect to OpenAI to ask the large language model. And then we need to create so-called chain, conversational chain, to have like a real conversation with chatbot, so the chatbot would remember what you said in the previous message. We will talk about that memory in a few minutes, but for now, let's tie it all together. So we create the LLM model, chat OpenAI, with the same OpenAI key, and we pass that LLM model as a parameter to that conversational retrieval chain object. Let's close the sidebar so you would see it better. And another parameter to that chain is our vector store. And we need to pass that as retriever. That whole concept is called RAG, which stands for Retrieval Augmented Generation. So we retrieve the relevant documents and then we generate the LLM answer with those documents in mind. And now we can launch that chain with real question. So this is an example query to our chatbot, and we provide that as one of the parameters to the chain. So we have a set which contains question and required parameter chat history, which is empty for now, and we will get to that in a minute. We launch, we ignore the warnings, and this is our result. Question: do you have a team plan? And answer is this. Yes, we offer a team plan. The team yearly plan allows for up to 7 members and other relevant information. So yeah, our customer support agent has just answered their first question. But again, a reminder, the answer to that question was not free. How to calculate that cost? Of course, you can go to OpenAI platform and see the usage on the dashboard. And this is my personal usage for playing around with chatbots and other projects. And this is today at the time of shooting this video, but you see the problem immediately. The cost for embedding models is not really accurate, less than 1 cent, but how exactly less? And also it's just for embedding models, but didn't yet refresh with the actual GPT usage. And you can see that in activity requests and tokens. So GPT tokens and embedding tokens. But it doesn't really say much. To get a specific cost, we can write some code for it. And this is the code. So we wrap that chain into a structure of with get OpenAI callback, and we print the result of that callback. And to have access to that, we need to import that method from LangChain callbacks. Again, see how many things are with LangChain. So it's kind of all in one framework for all of those separate methods. Now we relaunch that, and this is the result. This is how much it actually cost us to run that query. So tokens are not really human readable, but this is what we actually care about, right? So it's 0.04 of a dollar cent, which is not a lot, but for 2 reasons. First, our query is very simple and our document is tiny with just a few CSV records, which means embeddings are quick and cheap. If you experiment on bigger documents with more complicated queries, the cost may be quite a bit higher, but still, it should be in cents or fraction of cents for one chatbot request. And again, that's the price of the default model of Chat OpenAI, which is GPT-3.5 Turbo. If you try to use GPT-4, it's I think at the moment 10 times more expensive. And again, you don't have to use those paid premium models from OpenAI. There are open source alternatives, and I will show them in the future videos. But for now, we're focusing on the process of how chatbot works based on this OpenAI model of GPT 3.5 Turbo. Now, side note, a bit of refactoring. You probably have noticed that I use OpenAI API key twice, and there is of course a better way. In Python, we should do import OS, operating system, and that put that OpenAI API key into OpenAI API key value like this, which will help us with 2 things. First, we don't need to provide that twice, or in fact, we don't need to provide that at all, because by default, those classes of OpenAI embeddings and Chat OpenAI will try to search for environment variable with specifically that key. So this makes our code shorter, and we can make it even shorter without creating that temporary variable, and we can pass Chat OpenAI here like this and delete that line altogether. So just a little cleanup. the final step working on the back end of our chatbot, so how it works, and then we will get into how to present it and how it looks, the front end. So now the memory, that chat history that I've mentioned already, it's empty, but we need to fill it in with history after every response, right? And the most straightforward way would be to do something like this. So history, local list variable of Python, then we pass that as a history once and then append the answer to the history, passing that again, which means that our chain is aware of that history and would pass that to the LLM GPT. But there's a better way, again with LangChain. We can import a library called conversation buffer memory from LangChain. Then we need to create the object, passing the memory key as we want to call it, and another parameter to return the messages into memory, and we need to pass that as the third parameter to the chain. And then our chain doesn't need to have that second variable of chat history because it is baked into the object itself. So let's try to launch something like that. So query, and then another query with a different response, and let's see what we have as a result. Our chatbot is sincerely honest. From that information, it doesn't calculate or figure out what the member actually is. Let's change it to, for example, 5 team members. Relaunch again. And by the way, in terms of speed, that answer takes roughly 5 to 10 seconds for 2 chains. And now we do have the answer like this. And now we can finally get to presentation of our chatbot, and we will do it in 2 ways. The first way would be terminal-based CLI Chatbot with inputs and presenting the results. And then the second one will be a web-based page with another tool called Streamlit. To properly do that, we need to refactor this main.py into a separate file which would be called from both CLI and web scripts. So let's rename that file in PyCharm. Let's call it chain.py. And let's transform all of that into a method, into a function of Python, which would return our chain. And then we will call that chain from both web and terminal. So define get chain as a method. And then we do all of that inside with indentation, but we don't do query here. The query will be outside. We just return the chain as an object. New line at the end of the file, and new line before the function. This line isn't really necessary. And then let's create another file, Python file called terminal.py, where we will import from chain, import get chain. And then we can call that chain equals get chain and launch our query from terminal script. And this is the full code. Again, I've copy-pasted it from my notes to avoid live coding typing. This is an eternal loop. We're prompting our user until they enter the word exit or quit or whatever. To exit the script, we need system exit and import sys from Python. And then we launch that chain with questions. And if we launch that current file, we have a proper prompt down below. And we can actually chat with the chatbot. So, do you have a team plan? Again, the answer, yes, we do have a team plan, blah, blah, all the text. What about free plan? And the answer comes based on the given context. There is no mention of a free plan. And you can add more questions and get the answers until you hit exit and then process finished. So we have our terminal-based chatbot with OpenAI. Cool, right? Now let's build the web version, and to do that quickly I will use another tool called Streamlit. And this is not a video about Streamlit specifically, so I will not explain it in depth. I will just show you the code similar to this on their homepage. We will import Streamlit and do st-write, st something like that, and specifically for chat they have specific functions which look very simple but achieve exactly what we need. Let's create another Python file which would be web.py, Python file web.py, and this is the code. Again, I've pasted from my notes and we will get through that line by line in a minute. I just need to install Streamlit as it is underlined by my PyCharm. So install package, installed successfully, and now we can get to the code. I will close the sidebar again so you would see that. There are a few things that we use from Streamlit. From ST, we will save the messages into a list of session state messages, and each message will contain a set of role, whether it's bot or not, and then content. And we start with a simple message with role bot, and then our bot will have a logo, which is the same logo from Python ML Daily on Twitter. Then we need to show all the messages. For loop of Python, if we have a bot, we show the message with bot logo. Otherwise, we just show the message without any logo. And then at the bottom, we need to query the user. And for that, Streamlit has chat input. Then we append the input as a message to the session state again, show that with ST Markdown, and then we provide the answer. And here's our chain in the middle of it. First, we create an empty placeholder, like we're waiting for an answer, and then as soon as we get that answer, we put that as a markdown. So this is to visualize the message, and we need to also add that to the session state. And to launch that in the terminal, we need to run Streamlit, run, and then our script, which is web.py. We're executing, and it should open like a new server in the browser, running, and let's see what it does. Hello, how can I help with the bot logo? Do you have a team plan? This is looking like exact chatbot, right? Like ChatGPT or something. It is calling the API, and something is wrong with this markdown, but you see the answer here. Let's try to, what about free plan? Again, the same example. So it is appended at the bottom, and I'm sorry, I don't have that information, comes from the chatbot. So now we have the web client in the browser with Streamlit, working with the same OpenAI and the same chain from our backend. And there are a lot of things that we can polish, like this markdown, like the warnings in the pie chart, but I will deliberately not do that in this video to make it shorter. This is about process and the main logic of how chatbots work with LangChain, RAG, and OpenAI GPT as a model. The source will be available on GitHub. I will link that in the description below. And from there you can experiment. Change the model, change vector databases, change prompts, and other stuff. And I will shoot more videos about chatbots in the future, improving this one, so there will be a follow-up definitely. So subscribe to the channel to get more videos on Python and machine learning daily. Also, as I mentioned in the beginning of this video, this full course is available in text format on pythonmldaily.com, and I will link that as well in the description below. That's it for this time, and see you guys in another video.